Hello and welcome to my channel. In this video, we are going to answer a fundamental question for any developer. What is Git? We'll start by looking at the problem Git solves, exploring what life was like before modern version control. Then, we'll define exactly what Git is and what makes it a distributed version control system. Next, I'll walk you through the installation process for Mac, Linux, and Windows. After that, we'll dive into the core concepts, starting with the three fundamental states: the working directory, the staging area, and the repository. We'll then cover how Git captures snapshots of your project using commits, tags, and branches, and understand the role of head. We will also learn how to combine work from different branches using merge and rebase. Finally, we'll look at how you collaborate with others using remote repositories with fetch, pull, and push. By the end, you'll understand why Git is an essential tool for modern software development. Let's get started. Before we can appreciate what Git is, let's travel back in time and look at the problem it was designed to solve. Imagine you're working on a project, maybe a website or an essay. To save your progress, you might copy the entire folder and rename it something like Project Version 2 or Project Final. If you're like me, you probably ended up with a dozen folders with names like Project Final for real this time. This was the reality for developers. It was messy and unreliable. There was no clear history of changes. If something broke, you couldn't easily see who changed what, or why they changed it. Collaborating with a team was even worse. People would work on their own copies and then try to manually merge their changes together. It was incredibly easy to accidentally overwrite someone else's work. And what if you introduced a major bug? Trying to roll back to a previous working version of the code was a painful and often impossible task. This chaotic process was a huge bottleneck in software development. Next, we will see how Git provides an elegant solution to all these problems. So how does Git solve all those problems we just talked about? At its core, Git is a version control system, or VCS. Think of it simply as a program that tracks every single change made to your project's files over time. It's like a super-powered undo button for your entire project. More specifically, Git is a distributed version control system, and this is its most important feature. Imagine you're working on a team. In older, centralized systems, the entire project history lived on a single main server. If that server went down, nobody could work. Git completely changes this. When you use Git, every single person on the team gets a full, complete copy of the project's entire history on their own computer. This means you can save changes, create different versions, and view the project's history, all while being completely offline. It also means the system is incredibly fast and resilient. If the main server is unavailable, you still have everything you need right on your own machine. In the next section, we'll get our hands dirty and see how to install Git on your computer. Alright, let's get Git installed on your machine. In most of the modern operating systems, Git comes pre-installed. To validate if Git is already installed, open your terminal and execute the git version command. If the command returns a version details, congratulations! Git is already installed in your system. Even if Git is not already installed, the good news is that it's a very simple process on any operating system. If you are on a Mac and use Homebrew, you can just open your terminal and type brew install git. If you are on Windows, the best way is to go to the official Git website, which is git-scm.com. There you can download the Git for Windows installer. Just run the installer and follow the on-screen instructions. Accepting the default options is usually the best choice for beginners. For Linux users on a Debian-based system like Ubuntu, the process is also straightforward. First, you run sudo apt update to refresh your package lists. Then, you run sudo apt install git. For Red Hat or CentOS, try the yum or dnf package manager based on the OS version. Now that we have Git installed, let's explore its most fundamental concepts, starting with the three states. Now let's look at one of the most important concepts in Git. Git manages your project across three main areas, or states. Understanding this flow is key to using Git effectively. First, you have the working directory. This is simply your project folder on your computer. It is where you edit your files, add new files, or delete files. Next, there is the staging area. Think of this as a preparation area. When you have made changes that you want to save, you do not save them directly. Instead, you first add them to the staging area. This lets you choose exactly which changes will go into your next snapshot. Finally, you have the repository. This is the hidden.git folder in your project. It is the heart of Git. The repository stores every version or snapshot of your project that you have ever saved. When you are happy with the changes in your staging area, you commit them, which saves them permanently to the repository. In the next section, we will look at what those snapshots are called. Once your changes are in the repository, Git manages them using a few key concepts. Let's start with a commit. A commit is a permanent snapshot of your project at a specific point in time. Each commit is given a unique ID and is stored with a message describing the changes you made. Think of your project history as a long chain of these commits. Next, we have a tag. A tag is just a friendly name you can give to a specific commit. This is very useful for marking important points, like a version 1.0 release. Then there are branches. A branch is like a separate timeline or a parallel universe for your project. You can create a new branch to work on a feature without disturbing the main, stable version of your code. Finally, what is head? Head is simply a special pointer that always points to the branch you are currently working on. It tells Git where to add the next commit you make. Now that we know how to work on different branches, let's see how we can combine that work. So, you have created a new branch and finished your work. How do you get those changes back into the main branch? Git gives you two primary methods for this: merge and rebase. First, let's talk about merge. Merging takes the work from your feature branch and combines it with the main branch. It creates a special new commit, called a merge commit, that ties the two histories together. Your project history will show exactly where the two branches came together. The second method is rebase. Rebasing takes your changes and moves them to the end of the main branch. It essentially replays your work on top of the latest changes. This results in a much cleaner, linear history, as if all the work was done in a single line. Sometimes, when you try to merge or rebase, you might get a conflict. A conflict happens when changes were made to the exact same line of code on both branches. Git does not know which version to keep, so it stops and asks you to fix it manually. Next, we will learn how to share our work with others using remote repositories. So far, everything we have discussed happens on your own computer, but the real power of Git comes from collaboration. This is where remote repositories come in. A remote repository is a shared version of your project that lives on a server, for example, on a service like GitHub. So how do you keep your local copy in sync with the remote? First, there is fetch. The git fetch command downloads all the latest changes from the remote repository. However, it does not automatically integrate them into your local work. This is useful if you want to see what others have been working on before you merge it into your own branch. Next is pull. The git pull command is a combination of two other commands. It first fetches the latest changes, and then it immediately tries to merge them into your current branch. This is the most common way to update your local repository with the latest work from your team. Finally, we have push. When you have made and committed your changes locally, you use the git push command. This uploads your commits to the remote repository so that the rest of the team can see your work. In our final section, we will summarize why Git is such an essential tool. So let's quickly summarize why Git is a developer's best friend. First, it acts as a complete safety net for your project. You have the entire history of every change, so you can go back in time whenever you need to. Second, it makes collaboration incredibly powerful and efficient. Teams can work on different features at the same time without interfering with each other's progress. Third, Git gives you the confidence to experiment. You can create a branch to try a new idea, and if it does not work, you can throw it away without any harm to the main project. Finally, knowing Git is no longer optional. It is a fundamental skill that is expected in almost every development role today. It truly is the foundation of modern software development. I hope this introduction has been helpful. Thank you for watching. If you liked this video, please give it a like and subscribe to the channel. Don't forget to hit the bell icon to get notified about new content. A link to the code and the markdown file for this presentation is included in the description section below. See you in the next video.